Woo! What is going on, guys? It feels good to be back with another episode of Vesting. Let me see what we got. Wait. Let me fix this. There we go. That's a little better. Yo, what's up, Camille? What's going on? Welcome. We are back with another episode of Vesting. Oh man, it's so interesting doing this from scratch again. Like the whole having the vesting Twitch and the vestings, vesting having its own YouTube and all these things. I love it. Don't get me wrong, but I also think it's quite interesting because I'm going through the process of building this and like creating almost like two separate worlds. It's like we have vesting, we're together, but we're also separate. And we're back with another episode of Vesting. And it should be quite fun because the startup we're chatting with today is a little bit out of the ordinary. These guys train AI coding models, like to make them better, faster, cheaper. So it'll be I feel like there could be like a deeper technical avenue here, which is fun. But one thing I will say, the vesting Twitch has hit 10 followers. I know, don't all clap at once. Insane milestone, insane moment. But man, I don't even know. Camille, have we been keeping track of shows? I don't think I've kept track of how many we've done. But our numbers have to be moving at this point, right? Like we've done a fair amount, I'm pretty sure. And let's add another one to the list. So yeah, we're chatting with, let me just pull up their information really quick. Say to me, my heart be bound. We are chatting with today. We've done 25 episodes already. Is that just this year alone, or is that including this year and last year? I mean, either way, it's a pretty insane number. That's just this year. Wow. Counting Artifact? Yes, counting Artifact. So we're 25 episodes in. 25 is my birth number. Day of the month, April 25th. So I'll take it. 25 episodes in, a quarter century. And today we are chatting with the good team over at Halandir. So let me pull up their info for some slight insights. We are chatting with Halandir. Should be fun. Some of these companies, for me, it's like getting a deeper sense of where they see gaps in the market. And I think that's what we're going to get chatting with Halandir, because building operational superintelligence, there isn't much about them on the internet. They don't post much. They're very secretive, and maybe they're not being secretive on purpose, but when you're building in the category they're building in, which to my knowledge is them like making coding agents smarter, faster, but also just making running models more economically efficient in general, you kind of don't want to give out all of your secret sauce. So with that said, today we are chatting with Gibran from Halandir. So we have him backstage already. So let me bring him up. And I hope I said your name right. It's Gibran, right?
Yeah, that's right. Gibran. It's a good pronunciation.
Appreciate it, bro. Well, it's a pleasure to have you on the show. A pleasure to have you on the stream. Welcome to Vesting. How you doing today?
Good. How about yourself?
I'm doing good, bro. It's like one of my favorite times of the day because I get to chat with you guys, like dope startups doing things that are just like, I mean, at times a bit unconventional, out of the ordinary, but that's the beauty in YC. And I don't think I don't think there's a better adjective to describe what you're doing, because most of the world probably won't see it up front, but it's very integral to where the future of the industry that is artificial intelligence, machine learning, training these models, making them more efficient, token expenditure. You guys are trying to fix some of the hiccups that come with that.
Exactly. Yeah.
Oh, well, I want to start this off by just kind of diving into your background and your team's background a bit, because, I mean, transparently, you guys pretty much said, screw school. You have an idea. You put together an absurd team, right? You got UVA, Princeton, you went to Carnegie Mellon. So, I mean, without a doubt, you guys are cracked. But, like, give me a sense of how did all of you guys from different backgrounds come together and realize you could build a company that is probably at the most difficult intersection, which is like training AI models?
Yeah. It's actually funny. We've known each other since elementary school.
Oh, wow.
So for more than a decade, we went to the same elementary, middle, and high school, all in the Northern Virginia area.
Shout out. What part?
It was Fairfax, Virginia.
Oh, no way. I was born in Fairfax Hospital.
Oh, awesome. Okay, yeah.
I'm from Woodbridge, exactly, so I'm very familiar with Nova. Shout out. Let's go, baby.
Yeah. Well, we were all from that area. Like you said, we all went off to school, and I sort of found some students at Carnegie Mellon and met with some professors that were working in the formal methods department. Sort of caught my eye, and the whole sort of inception of the company came out of our sort of want to combine AI with formal methods. That's sort of how it started. But yeah.
So you guys went to the same school, pretty much grew up together. Like, were you guys always interested in, tech, engineering, startups? Like, whose idea was it to just bring everyone out of their respective paths and go on like the most unconventionally traveled journey ever to say, we're dropping out of school to build a startup?
I think it was sort of mine, but we all worked together before that. So we did like a ton of hackathons. We won a couple of them. So we were like familiar with working each other before this. I think we knew going into school that we wanted to do something. We just wanted to make the right connections at school and sort of get the knowledge first that we needed to. And then after that point, you can sort of go and do things now. You can't just do things. So we sort of wanted to take that mentality out to a startup after we did school. But yeah.
You referenced seeing some of your professors working and researching. What did you come up with from seeing their work that made you realize there was a huge gap in the market for what you guys are currently doing?
Yeah, so there's this entire field of software verification called formal verification. A student actually at CMU introduced me to the whole concept, and there's a whole department dedicated to it at CMU. And basically, instead of writing a unit test that essentially checks an assertion, a part of some method, you're instead defining a formal specification of what a certain method should do. So like a precondition, a postcondition, a loop invariant, a bunch of these different like properties you can define across a set of code. And you can basically see, formally speaking, if your code conforms to that specification. So basically it's one of like the hardest and most comprehensive ways of verifying software. And I think that was really interesting to us because if you can get a large language model to reason through sort of this formal domain, whether it be through verification, whether it be through, for example, there's a lot of companies working on lean research, which is sort of this but applied to math. If you can get this and crack it for coding, the dream for like 20 years has been, can you make software formally verified? And if it is, that's quite a big deal. It essentially means no bugs in some instances.
Yeah.
But it's quite a powerful technology if you can get it right. It's been attempted at for a lot of years at this point, and not to say that it's crackable with AI. It's just that LLMs are super good at outputting a lot of stuff very quickly, like educated guesses very quickly. I wouldn't say like the underlying technology of the LLM has necessarily made it easier, but it just made it faster, and therefore like it's slightly easier. But yeah.
It's almost like what you're building could potentially, or the idea behind it is, LLMs can create things quickly, but as a byproduct of creating things quickly, there's a ton of tech debt. And this tech debt is kind of a byproduct of things not being tested to the fullest extent. But if you guys get what you're trying to get right, you can accelerate not only the process of building, but the process of testing that everything as it is built works. Like, I mean, ideally 100% of the time. We're never ideal, but like a vast majority of the time with no bugs.
Yeah, we originally wanted to do something that was strictly around like the end, the end part of the software stack. So you develop software, then you can go back and formally verify it. We realized very quickly that in order to write formally verified software, and this is not what we're doing completely, to be fair, this is one aspect of what we're doing.
Yeah.
You have to let the model write the specification initially. So it's sort of like the spec-driven development. I don't know if you heard of OpenSpec in our batch. They sort of have the same sort of thesis. We want to apply like models specifically to that thesis. But we realized quite quickly, you can't really do this at the end of the stack. You have to build this into RL. In post-training, you can get a model to understand how to write formally verified code. That's quite powerful. So we ran our experiment. We trained a model on this niche language called Daphne. It looks like C#, but it has the formal specifications built into the language.
Yeah.
And we essentially trained a 7 billion parameter model on it, got measurably better on live code bench, which is actually a Python benchmark. And the reasoning there is that the training a model on this very niche language, nobody's really used it, but it is basically a formal specification language.
Yeah.
The reward that we gave to the model was whether or not the code was formally verified, as opposed to what they do now, which is whether or not it passed a unit test. And that got us significantly better results on a Python benchmark. So it might have learned to generalize. That's sort of what we're thinking. But I guess larger than that, we don't want to just apply this to software. The reason why we call ourselves an operational superintelligence company is because we're trying to apply this to as many verifiable domains as we can. So logistics is actually a big one we're working in right now. If you can basically make constrained environments from typical logistics operations, you can basically not only create environments and working with labs to ensure that their RL post-training pipelines are better, but you can also go straight and directly to the logistics operators and basically tell them, hey, listen, we're going to take all your supply chain check. We're going to essentially model it with our own software. And we're going to ensure that if you throw an LLM and want it to understand all of your sort of supply chain operations, we can do that basically with 100% verifiability because of the methods we're using. So operations research problems, like we're using Gurobi solver, SMT solver, SAT solvers, different sort of, I guess you could say, verifiable sort of model checking techniques to make LLMs, I guess, accountable to the stuff that they're outputting.
So was coding kind of basically you guys' like entryway to the thesis that this sort of a thing can work in a very structured setting? But now, as you were saying, with the idea being operational superintelligence, applying the same results in the same methodology to pretty much anything where AI can, or anything that has a need to be verified in any instance, leveraging the AI training you guys are doing to basically do that, but across the entire sphere of artificial intelligence.
That's exactly right. And you would think like, the models can probably do this, right? We actually released a paper where we benchmarked the model's ability to write. It was like a typical OR sort of supply chain problem. It was given a set of constraints that it had to get right, and it was also given basically how optimal is that solution. We tested this across all the top models, so GPT 5.2 Pro, Opus 4.6, and the questions were around 200 questions, and the paper's on our website. But basically, the question was, is this question right? Is the answer correct? And is it the most optimal? And the best model got around 30% on that benchmark, which is GPT 5.2. So there's clearly a lack, and these are like relatively simple, like textbook OR problems. There's clearly like a lack of understanding of how to reason through verifiable domains. And I think there's a lot of reasons for this, but some of the main ones concern both post-training, but also how do you actually deploy these models effectively at scale? So there's like different areas you can apply this sort of thesis of verifiability. Right now we're targeting coding and logistics, but I think that can expand as time goes on.
Why do you think we're talking OpenAI, Anthropic, they've raised billions of dollars. Why have they not been able to solve these sorts of problems that you guys are going after at scale? Like, what has been the bottleneck?
The bottleneck of basically modeling these complex systems at scale is simply the complexity of the system. If you have to model, say, like a certain business's supply chain, number one, that information is quite sensitive. So they're not going to give it out to the lab just to do post-training over it. That's why a lot of these companies end up using on-prem models, local models. They do their own post-training, their own supervised fine-tuning. Another aspect is sort of like making something objectively verifiable. The objectivity of that verifiability is sort of like hazy. Like I can say, for example, that something is deemed correct, but is it the most correct thing? So there's like these certain there's these certain I guess like vague sort of representations of what is deemed to be correct, and our sort of goal is to universalize what is correct. It's a very like ambitious goal, but I think the main reason why it's so difficult for these labs to go out and do these things is simply because a lot of it is really boutique, and that's why we're implementing some forward deployed engineers into some of the companies that we might be working with. So it's sort of a matter of the complexity of modeling hard things. Like code is super easy; you just have a unit test. But for something like a logistics supply chain, it's significantly harder to model.
Because there's no one way or one size fits all approach to what is the best path to get this item from one place to another, or, you know, have our oil tanker deciding which route it goes to get, you know, oil to one location, whether it's above the Arctic or below, right? Like you have based on previous attempts to go and do the thing, you have that, but based on the data that you're receiving right now, what is the most correct way to do a certain thing?
Exactly. And like you can take like the Iran war right now with the closing of the Strait of Hormuz, like random events like this very much impact your models. So it's sort of hard, you know, if the model weights are static and they're not changing, it's very hard to encode these sort of changes that are happening all the time. So that's something else that we're looking at.
So I want to switch gears a bit because I feel like we're going to come back to this topic in a few. And I'm very intrigued by it, but I want to know more about you guys' YC experience. Like, was this your idea too, to be like, hey, let's just go apply to YC. If we get in, we quit. If not, we keep building in our respective colleges.
Yeah, I think it was all of our decisions to do YC. I think the primary thing that they're absolutely amazing at is focus. So they will force you to ask like difficult questions. If you notice, like a lot of sort of like the VCs you might interact with, they're a lot of yes men. So they're like sort of giving you confirmation bias.
Yeah.
Whereas with YC, at least in our experience, they will tell you when you're wrong and when you're right. And they'll give you advice that's hard to hear, even if like it's difficult to take. And that in and of itself is like a very useful thing. Like they will guide you to be on the right track for almost anything you do.
Do you think that most VCs would rather err on the side of glazing you so that they're not on the wrong side of history versus just being straight blatantly honest and being like, this sucks because this, or etc.?
Yeah, I think that's correct. Yeah, I think a lot of them will sort of be like, oh, I don't really want to criticize this idea because it might work, and I want the founders to sort of push this idea. But the sheer numbers that YC has seen over the years gives them like a ton of data. So they know very like 99% of the time they're going to be correct in their advice because they've simply seen so much of this happen over time. And like there'll always be that, you know, you'll have that feeling like, oh no, we know best because it's our company. It's like, yes, but a lot of the time the partners are exactly right in their advice. And I think that's been like the most helpful. They also sort of say like a lot of founders in the batch are sort of wondering, does the calculus of doing YC change as software, basically the cost of writing software is going down to zero?
Yeah.
And I think it is even more valuable in that sense because before, I think the sort of impetus of doing YC was they would give you sort of the guidance, maybe it's the technical guidance or sort of the I guess the more financial guidance as to how to operate your company.
Yeah.
But now because the software is down to zero, the thing that matters most when building a company is not honestly the technical difficulty. It is nowadays sort of how you position yourself both as like as a business in terms of who you're selling to, who your customers are, but also sort of how you think about the whole operation of the company. And that's why YC is like, I think more important than ever, is because software is so easy to write now.
You give a very interesting perspective because a lot of founders, I chat with a lot of founders, a lot of you guys that are in YC. And when I look at you, I think these are some of the most exceptional founders being brought into one area to sprint, right? And sometimes I sit on here and I think to myself, yeah, I could feasibly be chatting with the next Elon, the next Sam Altman, the next whoever, right? And not just to say that it'd be like, oh my God, like YC is so great, but more so from the perspective of when you've seen a lot, and I've seen a lot of startups and I've seen a lot of high quality startups, and I previously built one myself, and you understand kind of what it takes and how that's changed from just a couple of years ago. And then you see the crop of founders where people will just be like, hey, I want to build this thing and raise venture capital. you realize that most founders would do a lot better either bootstrapping until they are impressive enough to get into an accelerator like YC, or until they have enough traction to be able to go out and raise an actual round for that thing. Because to your point, YC 15 years ago, it was like, oh, we're doing YC or you're raising money because you need engineering talent to like build this thing and we're going to like front you the money. Now it's like everyone has the engineering talent to an extent, maybe not in what you're doing, right? Like, I don't think someone could come and be like, hey, we're going to go try to build Halandir and using fucking Claude and, lack of experience. But we're at that inflection point where building is so easy that the soft skills are the hardest things to come by. Like how you sit in a room with your co-founders and decide on which way to go or direction or decision, whether it's something big or something trivial, or how you position yourself and market yourself and all of these different ways and all of the little things, to your point, that YC provides. When you look at your experience so far in the batch, you're 2 months in, demo day at the end of this month, how would you rate the experience to this point?
I think it's like I would say like an 8 out of 10. Obviously there's like difficulties with, like you have to argue with your co-founders sometimes. You have to come to terms with like, are you going too hard in a certain area? Do you need to pivot somewhere? Obviously that's very difficult, but I would say the experience has been, at least for on YC's part, has been phenomenal. They really do provide, obviously the community is great, right? They will tell you, what to build.
Yeah.
You'll sort of like, bounce ideas off of each other. And I think it's just cool. They actually put you in groups which are like your company. So you'll be like doing office hours with like a company that's very similar to you.
That's actually dope.
Yeah. So a lot of like the companies that we've been talking to, they're also doing research, for example. And, like you said, because everything's so easy to do technically now, the hard things are the researchable things. So what we do like 50% of the time is reading papers, things that are coming out, newer things, and basically trying to, it's quite simple, trying to amalgamate all of the information that we have from these disparate resources and sort of come to like a singular product or a paper that comes out of those things. I think the value of doing like very hard things is way, way, way higher nowadays because, writing like a SaaS is very hard to do nowadays, I think.
Yeah.
Building a SaaS is quite simple, and it seems like all of them are sort of have been created at this point. So the harder things that you can do, whether it be robotics, so obviously like physical things are super cool to me just because they're obviously very difficult to do. But also like very hard research questions, I think those are going to become much more valuable as time sort of increases. And I think YC will be selecting for more research-oriented companies in like the coming batches, simply because the labs have seen to basically make all of what, or at least a lot of what is coming out of all Silicon Valley right now. Yeah.
You said that you spend a lot of time like researching and reading papers around AI. If I'm someone who wants to keep up with, cutting edge AI research papers, what's one place you'd recommend I go to like find some of that information?
Yeah. What we're doing is like super like specific, the papers we read. They have to do with like formal methods and RL and stuff like this. But I think for like the best information, probably like Interconnects. That's a great newsletter by Nathan Lambert. He's at post-training at AI2, the Allen Institute. There's also great information. If I can find it. Deep Learning Focus. That's a great one.
You're dropping
gems. Definitely resources out there. Yeah, there's like a bunch of resources out there that are great. But I think a lot of it is just like finding an area which you're super interested in and just doing like a deep research session or searching archive and reading all the papers that sort of appear up on there. But yeah.
Damn, you just dropped gems. If someone's listening, now I have to go and add all those to my stack, man. But we were about to shift gears because I'm taking you into the Warp Speed Lightning Round. Our show is brought to you by Warp. They're an AI company, AI, HR, compliance, and payroll company. So who are you currently using to run your HR, compliance, and payroll?
Payroll, Gusto, compliance. We're not doing SOC 2 right now. We don't really need to because we're not selling like a SaaS.
Yeah.
And then is that it? What you said? Was there another one?
Was it HR, payroll, and compliance? So I guess your payroll and HR would be in the same spot.
Yeah. Well, I guess Gusto for both of those, but might need to do Warp eventually.
Maybe I can convince you. But right now, I'm taking you through 5 rapid fire startup questions. Answer them as quickly as possible. Let me know when you're ready.
All right. I'm ready.
All right. Question number 1. What's one green flag that instantly makes you like an investor?
Their understanding of the technical aspects of the product.
Number 2. What's more important? Having a work hard culture or having a team first culture?
Sort of both, but if I had to choose one, probably team first.
Okay. I thought you were gonna pick the other way. All right, third. Would you rather raise money too early or bootstrap too long?
Bootstrap too long.
I fuck with that. Getting the leverage. Number 4. What is your VC lie detector question? If you're chatting with a VC, they're nodding their head, acting like they know what the fuck's going on. What's one question you're asking to determine where they stand?
Determine where they stand on the investment?
On what you're building.
Let's see. Have you heard of formal verification? I don't know.
I mean, I'm gonna be honest, I hadn't until we got on this call. So
well, no one really has.
Yeah.
So.
All right, last one. Would you rather build in public or build in stealth?
Build in stealth, absolutely, especially now.
Yeah, I'm thinking like for your business, it makes more sense to build in stealth. Like you can't be going out putting the sauce in public and then you look up and you got like 15 clones that are like Halandir for X, Y, and Z.
Yeah, that's very true. And we do open source some of our stuff, but not too much.
Man, you have made it through the round in flying colors. Transparently, the guy I had on here yesterday, it was like a minute per question. I was like, I couldn't even finish all of them. I was like, damn, bro. But you came through. I appreciate you jumping in on the fly. I want to jump back into what we were chatting about earlier. And at first I was thinking it would just be about coding. But even beyond just coding, because although your initial sub or discipline for this is like the use case was coding, I'm intrigued by how many real world applications verifiability can have when it comes to decision making or AI
Absolutely.
learning how to make the right decision, and how much of that aligns very closely to what's needed for AI to actually reach AGI to be able to make autonomous decisions without having anyone checking behind them. Like, I think there's something interesting about that. So like when you look at kind of what you're building, how smart do you think you can make AI become based on where the current baseline is?
Yeah, so I would say if we can start with code, that's good with me. The thing that I think is lacking from a lot of the environments that are being built, like when I say environment, I mean an RL environment for coding specifically, is the reward is very sparse. So a unit test is sort of, I would say, biased. Like if a unit test is bad, let's say, the reward is going to be bad. It doesn't matter how many unit tests you have. If they're lacking coverage across the code base, the reward is going to be very sparse. Whereas if you write like a very good formal contract, for example, like you write a loop invariant, you can prove properties upon each iteration of the loop and whatever value is terminated upon the loop, right? So a lot of these intermediate rewards are very easy to measure when you're writing a formal contract. That's why you sort of get into like this process level reward modeling, which we're working with. It's a lot easier, I think, and a lot more, I guess I would say, elegant to reward a model if it gets properties of the code correct, rather than like a specific return value. So I think that's sort of our thesis around code and how you're supposed to model it. Like we asked, in fact, we actually asked like 4.6, I think, to write a merge sort algorithm using Daphne, the language I was referring to. And this is like a very simple, obviously a very ubiquitous algorithm. And whenever we wrote it, even when we like did supervised fine tuning over like a 32B model, it could never get full 100% verification with that algorithm. And I think that's because they don't understand fundamentally how to write code on like the method level. I think the reason why we're seeing intelligence, in coding skyrocket is simply because the data. Like, of course, if you're going to give it a bunch of data and you're going to have like a decent reward, obviously it's going to seem intelligent, but does it know actually like what each component, how each data type is calculated throughout the method? I'm skeptical of that. So that's like the coding front. I would say on other fronts, what other domains are verifiable? There's a super cool research effort. I forgot which school did it, but basically they would take legal contracts and they would formalize these legal contracts into like Boolean logic, and they could see where like a violation in the law happened by just running a solver. So that was super cool. So there's like a ton of different domains which you can apply this sort of solver verifiability to. And our sort of goal as a company is to like, how many can we apply this to? I think you can, like, I'm sure you've heard of like rubric-based rewards. Those are sort of getting popular now, where someone will create sort of this arbitrary rubric based on a set of tests and then basically conform to that. We sort of want to replace all of this with solver-based approaches throughout the stack. This doesn't just include RL, by the way. This includes building environments and actual harnesses for models to make them understand while they're being deployed. So it's basically both of those aspects. But I would say it's definitely important to consider the fact that I don't think these models, and to be honest, like an LLM in and of itself, I think very soon we'll see, maybe in like 2 years, I don't think LLMs will get us to AGI. I don't think AGI really means anything, to be honest with you. It's a very hypey world. I think we are sort of in like a bubble around a lot of the research and technology. I think LLMs are really, really good at seeming intelligent, but I don't think they actually are intelligent. And there's companies like Inception AI doing diffusion LLMs and all this interesting stuff too. But the current paradigm is just not it, I don't think.
It's almost like, it's just to your point, right, around code, because there's so much data on what decent code looks like to get to a result. It's almost like all the AI is doing is pattern matching based on previously provided repos and the results of those repos when they are compiled, and getting so many repos that it has such an enormous amount of what good pattern matching looks like that it can regurgitate anything based on kind of like this deep embedded memory bank. But it's not going out and saying, you know, I'm going to go figure out something that is 100x better than how you would optimize a certain piece of code, because it doesn't exist in its code base by default. And it doesn't have the right groundbreaking methodology, like the right foundation to understand how to get to new breakthroughs and eureka moments. And that's across all of AI almost.
Yeah. That's a great way to put it, actually. Because the training data, let's say you have like a group of training data and it doesn't have the most optimal solution. In most instances, the LLM will not come up with the most optimal solution. So you have to let whatever it is, let's say we go past LLMs, whatever model you're interfacing with, it has to be able to reference these solver sort of technologies so that it knows, okay, this code is consistent to this code, but also this is the fastest version of this kernel, for example, right? So there's things that the model has to interact with outside of just the model. And I think we're realizing that, like a lot of the ArcAGI, the best models that are doing on ArcAGI, all of them are using this approach. Like they're just writing Python basically and doing evolutionary algorithm type stuff there. But I think you're exactly right. It's sort of like it's like a facade of intelligence, and there needs to be some sort of breakthrough in like the actual architecture for something to be interesting there.
Do you think that because companies like Claude and OpenAI, have raised so much money and have gotten to the point where they have had to commercialize, even though they're getting a ton of data, they're not fighting the innovation breakthrough game. They're fighting the AI commercialization game, where it's like, who can commercialize the fastest and not who's getting the unique and interesting breakthroughs. And to your point, maybe that does come from people like you who are providing more boutique solutions, because you're not just hyper incentivized by how do I get as many users in as possible by doing whatever else my competitor is doing.
Yeah, I would say, I think Anthropic, I think all of their approaches are great, to be fair. I do think they are doing a lot of research that they're probably not telling us.
Yeah.
And I do think, like, if you get a model, the reason why code is so amazing is because it's sort of in like a middle natural language.
Yeah.
But you can train on that natural language, and that natural language is verifiable. It's basically like verifiable English, right? If you can train a model on that, of course it's going to be great. So I do think their approach is correct, and I think they're going to be doing great. And that on that front. However, for the fundamental architectural differences, I do think you're exactly right. You can't really have you can try to balance like the commercial opportunity with the research opportunity, but for like the more like fundamental things, and to be fair, we're not working on those fundamental things. We're not doing architectural stuff. We're basically doing post training, which is under the current paradigm. But companies like Sakana AI, for example, their continuous thought machine came out a bit ago. A lot of these sort of like architectural changes should be left to companies like that. Like they obviously have a clear commercial vision, but also they understand from the inception of the company that the company is made for research. We want to do both. We don't want to just be a research lab. We want to be an applied product lab,
Yeah.
doing selling to both the labs and also selling to, of course, the logistics companies. But for companies like Sakana, Inception AI, I think there should be significantly more fundamental research companies that aren't just building off of the current paradigm and are actually changing the paradigm itself, which I think is a great example of that.
No, I mean the way you explain it is like it's very well done, because anyone listening could take this conversation and yeah, there might be parts that are like, oh man, this is a little over my head, but it's broken down in a way that's like, hey, here's the problem, here's what we see, here's kind of what the industry is doing, here's how AI is currently working, and we think there's something bigger. Before we jump to one of the last segments, you talk about the next wave potentially being something that goes beyond just large language models if we want to get to AGI or wherever we're supposed to go. Like, what are some other dynamic models you think could be the next evolution beyond just LLMs?
Yeah, I would say a lot of our research doesn't focus on that, but I would say for sure what the continuous thought machine. I am not intelligent enough to explain how it works, but it's very interesting. Apparently, they have some sort of neurons. They synchronize the neurons in some interesting way. There's also diffusion LLMs are super interesting because diffusion, obviously you see Mercury 2, which just came out. I don't think they released the parameter size, but I estimate it to be between like 10 and 25 billion parameters.
Yeah.
Not only is it extremely fast, like compared to Claude 4.5 Haiku, which has 89 tokens a second, this has like 1,000 tokens a second.
Wow.
Way faster, but also is more intelligent on every benchmark. So that's not obviously it's obviously useful in when you're using the model on inference. But imagine training, right? Training goes exponentially faster if it's outputting tokens just way faster. So I think that's definitely an interesting architectural change. But on more like fundamental stuff, like one of the partners in the batch is anti sort of back propagation. He thinks that that's not how neurons actually work. So we don't do that type of research, but I think there are companies out there trying to do like the more like serious types of like fundamental changes within the models themselves. That's over my head, but I think there are interesting companies doing that for sure.
Now I want to switch gears and direction. You guys are in the current batch. You're building a company at the intersection of AI training, like with your best friends, the people you grew up with. Like it's a very unique position. If you had to give like just any piece of advice to someone that wants to take that leap, whether it's with their friends or by themselves, and jump into AI and build a company and maybe even get into YC, what would your best piece of advice be?
Yeah, I think Reid Hoffman said something like this, but there's so many contradictions within building a startup. Like you need to go fast, but you need to also be slow enough to to do valuable things. You need to shoot for the moon, but you also you need to shoot for what's realistic in the near term. You need to have a long-term vision and have a short-term way to attack it. So there's all these like conflicting areas. I would say like one thing that is like consistent is work on things that are not easy. Like do things because they are hard, not because they are easy. Obviously the John F. Kennedy quote. But I think that's very valuable today. Like, let's be honest, it's very easy to just use Claude Code and build a SaaS. But I think because it's so easy, as with anything, that will become less valued over time. The things that will become valuable are genuinely hard things. So, for example, do like good research in areas. And if you need to stay in school for a little bit more, do it, I would say. Like, don't do things because they are hard, not because they are easy. So in that sense, don't just like drop out to build like a SaaS or something. Do something that will, sure, there are valuable SaaSes, but don't, do something that's like super crazy. But I would say like do things that are hard, both on the hardware and software side, because you enjoy to do them, not only because that might be the hype cycle, because there is a ton of hype right now. And I think it will calm down eventually. But if you're going to work on something, make sure it's something that will sustain the hype and be around for many years, not just the next 2.
Damn, you dropping gems, man. For early, what are you, like 18, 19 years? You're like 19 years old, right?
Yeah, we're all 19. Yeah.
Jesus, man. Yeah, very wise for your years, and I'm excited to to link up with you at demo day and things of that sort in a couple weeks. But you got to go through one more rite of passage that I put every YC founder in. You got to go through the YC arena. You are going to be a YC partner and rank 3 people's pitches and determine whether or not they got into Y Combinator.
Oh, are these actual examples?
Yeah, these are real pitches.
Interesting.
Yeah, it'll be fun. It'll be fun. You'll go through a couple of these, and basically at any point in time, if you feel like you know the answer of whether or not they got in, you can just stop me and you can say accept or reject. And if you want to give your reason or rationale, you can as well. All right.
Sounds good.
We're jumping into number 1. Let's see what we got. Oh, I fucked that up. Sorry.
Hi,
Sorry, my bad. All right, we got these two. It's okay.
I'm Liz.
I'm JJ.
I am the co-founder and CEO of Campus Job.
I'm the co-founder and CTO.
So Campus Job is an online marketplace for college students to find part-time jobs during the school year and for businesses to find students.
Reject.
Yeah.
Oh my God, they actually got in.
Yeah.
I'm not gonna lie though, the aura wasn't there, so I probably would have said reject too. But Way Up was accepted in 2015. No wonder, it was just like old. So this one is also a 2015 application.
Hey everybody, I'm Kamar. I'm a former Google and Apple engineer, now focused on my own startup called Flip. And Flip is a mobile platform that facilitates the fastest, guaranteed resale on specialty items, starting out with limited edition sneakers. Why sneakers? Because it's a huge shadow economy. And I know this, I'm a sneakerhead. I've been one for quite a long time, specifically age 9, just as long as I've been coding. And I wrote a couple of bots.
Accept or reject?
I kind of want to say accept.
I was thinking so too, but I feel like he just hasn't given much of a thesis. You want me to keep going, or you want me to just?
Sure, keep going for a little bit, maybe.
Yeah.
A few years ago that have now powered this 6-figure business that I helped co-found called Prestige, that's located in the Bay Area. What we're trying to facilitate with Flip is something that scratches at the human behavior and psychology of wanting to liquidate your assets extremely quickly. I know firsthand from this experience, so I'm trying to figure out how and when to sell my sneakers due to like pain associated from eBay and Craigslist and other social media like Instagram. Hey,
All right, that's all we got. Interesting.
I would say I didn't understand like the ending, so we'll just say reject.
Wow, Flip got in also? Honestly, I did. When he said Google engineer, I was like, okay, it's bullish, but I didn't know if he got in because he didn't say anything about like traction or like, it was kind of just like, hey, here's my thoughts, but okay.
Yeah. Well, I was confused at first because I saw communism, but it said, does that say commercialism in the
I think it was commercialism. Yeah, let me see.
Oh, okay.
That's so weird. Interesting. Okay. Man, we're both stumbling. All right, let's end it on a good note here. We gotta get some redemption. Third pitch.
Hi, I'm John. I'm the pixel pusher of the two. Got a bachelor's from Ohio State and a doctorate from the California School of Professional Psychology.
And I'm Joe, the developer. I studied computer science down in Texas at Baylor University, and from there went on to study music at the California Institute of the Arts.
So met about 3 years ago. We were working on a freelance project together. We've become really great friends. But aside from that, we've since co-founded the development studio we currently run today, which is Beastly Creative.
Prior to that, I was heading up all mobile development and platform development on various set-top boxes over at Break Media for Break.com and all the other properties. And one of the things I noticed working in these larger companies like that was that email is just the worst productivity tool you could imagine.
Yeah, so what we're building, it's a next-generation productivity tool. It's to supplant this traditional workplace communication.
The redemption. Yeah, I didn't. They didn't get in, but I wasn't sold on that one. As soon as you said email, I was like, all right, bro, you kind of lost me.
Well, it's that, and also I think like I didn't feel the energy like the others. I think, yeah.
I mean, the other ones were a little bit more upbeat, but it's all good. We ended on a good note. That was a rough start, man, but we ended on a good note. I think I got tripped up too, and I play this game. I play it every day when I'm chatting with founders, so it's all good.
Oh, interesting. Yeah. I mean, it is, to be fair, it's very random.
100%. And like some of them, I mean, Sometimes you get easy ones. I think these were a little bit harder. It's also hard to judge the ones from 2015 because I see a bad camera and I'm like thinking with my 2026 brain. So yeah, like 2015, all the cameras were bad, but you still got the redemption at the end. And bro, I appreciate you coming on.
Yeah, no worries. It was great. Thanks for having me.
For sure. I think I might be cooking up the next time I'm in SF. If I cook up a dinner, I'm gonna do something for founders. I'm gonna shoot you an invite. Would love to like meet you and the whole squad.
Yeah, absolutely. We love that too. Just let us know after demo day. Yeah.
Will do. All right, brother. You take care. Thanks again for hanging.
Yeah, thanks so much. Bye-bye.
See ya. Man, that was a very enlightening combo. I think probably one of my favorite combos we've had in quite some time. Just super, the way he was able to break down what he was doing very easily. So I don't doubt that he's going to be ultra successful. Very good conversation. Very solid conversation. All right. I am going to go live on my main Twitch. We're going to chat startups, venture for probably an hour and a half. I got to get some work done afterwards. So feel free to hang around and go over to twitch.tv/Bryson and we'll be live in about 5 minutes. All right. Take care, guys.